So in this video I've put together a few quick slides about assessing the reliability of the data you've collected. So this goes in one of two ways. You can either do it from looking at your table of data, or you can do it from looking at your graph of data. So let's have a look at the table method. So what you're looking for in your table is the difference between the repeat readings, so these two here, your repeat readings, and the average. So I'm just going to go through and them one by one. So if you see here, the repeats on the first row for 0 are identical, obviously because they're all 0 and there's 0 potential difference. It's not a great reading to take, to be honest, to include, but it's there. So you've got 0 variability between the average and your repeats, so you've got excellent reliability there. So let's go down to the next one. So we've got 1.0, 1.2, average of 1.1. Again, they're within 0.1 of the average, so I would say, you know what, that's actually pretty accurate. So accurate? That's pretty reliable because they're pretty close to the average, so that's fine as well. And it's the same story for this one. The one I want to draw your attention to here, the red flag reliability wise, is this one here. Because if we look at the trend going down, we sort of see the currents, generally speaking, are pretty similar to the potential differences shown. Whereas we've got this one here, which is drastically different. And then if we take the average of these two and get 2.8, we've got 0.4 difference between the repeat readings and the average value. So that would flag up this set of data here as being unreliable and should be repeated. So that's a reliability red flag. So in terms of assessing the reliability, you're looking for your repeat readings to be extremely close to your average value. There's no hard and fast rule in they have to be within 0.1 or 0.2. It's just a case of looking at your data as a whole and seeing if there's any that leap out at you as being drastically different to the reliability of the others. So that's one way of looking at the reliability of your experiment. So let's move on to have a look at graphs. So if you want to assess the reliability of a graph, it's about looking how close your points are to the line or to the curve of best fit that you've plotted. So if your points are all scattered around your line of best fit, they're all pretty close. They don't have to be on it. They have to be close, like we can see in this diagram here. Then you've got yourself a pretty reliable set of data. So that's good. You've got your points close to it. If we look at this one here, immediately you'll notice this point up here. We've got an outlier on there. But you shouldn't let outliers influence too much the reliability of the experiment, because you can see these other points here are all closely scattered around the line of best fit. So apart from this outlier, I would actually say this experiment is pretty reliable. Don't let one value distort your thinking of the reliability of a whole experiment. One piece of data can easily be repeated. But yeah, so you've got your outlier red flag, but otherwise you've got a pretty reliable experiment there. And we've got this one. So we can see this line of best fit's been drawn using the criteria, so we've got half the points above and half points below approximately, so that's fine. What we can see is there's a massive gap between where the best fit line says it should be and where it actually is. So if we actually made error bars for these best fit lines, so if we continued on, you would find massive errors in these values. So we're looking at here and being like, you know what, this is not a reliable experiment. These points are not closely scattered around a line of best fit. So that's basically telling you that this experiment isn't going to give you any particularly useful conclusions because you just couldn't be sure of any conclusion you were drawing. So that's not a reliable experiment. So that's the two methods of assessing the reliability once you've conducted an experiment.